In everyday life, we see some objects at rest and others in motion. Birds fly, fish swim, and cars move. Atoms, molecules, planets, stars, and galaxies all are in motion. So, what causes the phenomena of sunrise, sunset, and changing of seasons? Is it due to the motion of the earth? If it is true, why don't we directly see the motion of the earth? We often realize that an object is in motion when its position changes with time. However, there are situations where the motion can be realized through indirect evidences. For example, we infer the motion of air by observing the movement of leaves and branches of trees. This video is based on Class 9 Chapter 8 Motion from NCERT. And in this video, we will learn all about motion. To know about motion, first, let us know what is rest. A body is said to be in a state of rest when its position does not change with respect to a reference point. I know what you're thinking about. What is a reference point, right? Let me put some more light on this. When we tell our address to someone, we also add near the gas pump or near the post office. Or when a delivery guy calls us, we tell him that please come to west side of the post office. So you are using gas pumps and post offices as a reference point to navigate them to your home. So a reference point is a place or an object used for comparison to determine if something is in motion. Now that you know about the reference point, let us see what is motion. Let us understand this with an example. Consider this a school and this a school bus. Let us find out whether the bus is in rest or motion. To find that out, we need to take a reference point. Let's take the school as a reference point. Now with respect to the school, the position of the bus is the same and not changing, which means the bus is at rest. Now the bus has started moving. How do I know that? Because the position of the bus is now changing with respect to the school. So we can say that the bus is now in motion. So a body is said to be in motion when its position changes with respect to a reference point. So to answer the question, we don't see the motion of the earth because we are standing on it. The same way, when you are inside a bus and you don't consider it moving until you see outside the window. So when you'll go to the moon and see the earth from there, then you can see the motion of the earth. The same way we see the motion of the sun from earth. Now, there are three types of motion: linear motion, circular motion, and oscillatory motion. First is linear motion. Just like the example we saw, the bus was moving in a straight line. So, we can say that it was traveling in a linear motion. In linear motion, the body moves from one point to another in a straight line. Second is circular motion. If you have ever been on a Ferris wheel, then you have been in a circular motion. So, circular motion is described as a movement of a body while rotating along a circular path. The third is oscillatory motion. Here you can see that the block attached to the spring is moving in a to and fro motion from its mean position. So we can say that it is in an oscillatory motion. So oscillatory motion is defined as the to and fro motion of an object from its mean position. In class 9th, we'll mainly focus on only the linear motion. When you talk about your height or weight, or when you go shopping and tell the shopkeeper the number of kgs of rice you want, you are basically talking about the physical quantity. So, physical quantity is a physical property of a material that can be measured. It has two types. The first is scalar quantity. Let us understand. So when you are talking about the speed of car or the distance traveled by car, you are talking about scalar quantities, where we don't have the information of direction. So, scalar quantity is a physical quantity that has only magnitude, not direction. You'll get it more clearly when we talk about the second type of physical quantity, which is vector quantity. Displacement, velocity, acceleration, momentum, and force are some of the examples of vector quantities. So when I'm telling you to go 15 kilometers in the direction of north, or I'm telling you to apply a force in the upward direction to lift this suitcase, then I'm giving you vector quantities because I'm providing you with both magnitude as well as direction. So vector quantity is a physical quantity that has both magnitude and direction. In physics, we study the physical quantities. So in this chapter, that is motion, we'll study the physical quantities of motion. So in the next video, we will learn about some of the physical quantities of motion like distance, displacement, speed, velocity, acceleration. We'll also learn what is a uniform or a non-uniform motion. We'll see how we can plot graphs for these physical quantities, and most importantly, we'll understand the equations of motion. So that is it for today. We'll meet again at the next one. Till then, keep learning.